And this is part 2 of high availability, advanced failover, and virtual machines. So you create your clusters. Of course, as with everything else, it's not just set and forget. You'll need to do some management, like validating the configuration. Maybe you'll need to add or remove nodes, or shutting down, restarting the whole cluster, removing or destroying it, copying any roles, or moving resources. To validate, it's simple through a wizard. To add remove, it's pretty much the same way, where you'll go through the add node wizard and add a server name. And again, that server already has to have the feature installed. The quorum settings will get updated. And to remove, it's a little easier. You'll just right click and evict. Shutting down a cluster will stop all the roles and the services in that cluster. You can, if you need to shut down the cluster, you can do it within the FCM. Same with restart. And you can also start a cluster service on a specific node as needed. You know, if one isn't acting up right, you could call it restart. To remove, it's similar, right-clicking the node and selecting remove. And same with destroying. It is also possible to migrate the roles, but you can't migrate these roles: the cluster aware, the task scheduler, volume shadow copy, exchange, or SQL. For all the other roles in the cluster, you would open the FCM in the target, and then right click and then select copy cluster roles. The source can't be where you're running the wizard. You have to run this wizard from the target. When doing maintenance, you'll need to move the resources from one node to another, because again, this is all about high availability and ensuring that whatever services we're offering through this cluster are always available. So the core cluster resources are like the quorum, the IP address and network name, and here's the 4-point process to making that move happen. Because like I said, it's never a set and forget. It's definitely something that you'll have to come back to upgrade, to manage, to remove, you know, to do your usual management work. And you can do some of this in PowerShell. Advanced quorum settings is within the cluster manager. You'll have these choices to use the default quorum, select a quorum witness, or advanced. If you select the quorum witness, which is the second option, you'll specify how you want the quorum witness configured, which could be a disk, a file share, cloud, or not. You'll be able to choose which nodes have a quorum vote in the cluster. By default, all of them do. And if you remove all voting from all the nodes. You need to have a disk witness because the cluster needs to know who is down and how many to bring up depending on how you configured it. So it needs to have a place to see who's up and who's down. You can set it up dynamically, so it chooses on its own. So you don't have to manage it, and it can handle that by itself. You can also use Cloud Witness so that your cluster essentially is connected not just on-prem, but also up on the cloud. Which could be useful if, say, your on-prem loses power and you have critical services running. By having this Cloud Witness, the Cloud Witness could take over and nobody would feel the difference. Your users would be fine, even if your on-prem system is out. So it's within Azure that you can set that up. There you create your storage account. You'll need some access keys that you'll add into your on-prem system. That way they're both connected together. And then you go through the configure cluster quorum wizard. Once it's all set up, you'll see it online. So if anything happens locally, our Cloud Witness can take over. Your cluster aware roles, are all of these that will be able to happen on-prem and on cloud. Your main three categories for generic applications could be these three for a failover cluster. With any generic, so like non-Microsoft specific stuff, it'll periodically query to see is that application or service running. And it does have fewer ways to find out if it's an operational state, but you can still use non-Microsoft services and apps. The file server role can be used also for high availability. So this can handle, a lot of file read and writes throughout a cluster. And if something goes wrong with one node, the rest can handle. So you can either have it as a scale out or general use. Once the file server is configured, then you have a couple more settings like continuously available, so that other nodes would have essentially grab a copy and clients wouldn't be able to tell the difference in case a server goes down. Again, having the two nodes and needing to evict one, you'll need to make sure that your roles are transferred. Doing an in-place upgrade can happen if you have server 12 and upgrading to 16, but you'll need to bring it down and then back up, since it can't really happen live. You can do a rolling upgrade, but that's available for the scale out file system or Hyper-V. configurations, not so much for the others. You can also do an Active Directory detached cluster without needing AD for network name management. It'll still use DNS, but it won't depend on Active Directory. You can also create workgroup and multi-domain clusters, as long as we have things like DNS set up properly and have the right accounts everywhere, and you'll be able to do that. You'll be able to manage multi-domains and workgroups through a cluster. Your storage space for a cluster is kind of similar to the earlier. You can create it through the wizard or in the Failover Cluster Manager. You can also do cluster-to-cluster replication, just like server-to-server replication. So if you have multiple databases, or sorry, multiple data centers, they can copy each other to stay up to date, to handle availability, to do all that kind of stuff. It is possible to use the Windows Server Backup feature on a node. Just kind of interesting, but yeah, you can do it on that. To restore, it can be the authoritative restore or the non-authoritative. Like for authoritative, it's rolling back a configuration to an earlier point. The non-authoritative, taking basically the configuration and replicating it. There are also stretch clusters. If there's an even number of cluster nodes with a Cloud Witness Quorum configuration, can be done for multi-site. And you can also replicate data between these stretch clusters. So again, you'll need a heartbeat setting. And you have some different settings for heartbeat that can be configured between these two clusters in order to talk to one another. You can also set site-aware failover clusters. So you have physical locations, and those become cluster nodes. So if a site goes down, the other sites will have copies of the information and will be able to fail over to a node at a different site. Similar to like VMware, where you can have a configuration and VMs move from one site to another. So in case the site goes down, life continues. You can do a very similar thing with Windows clusters. And speaking of virtualization, this section will do high availability within Hyper-V. So again, it is possible, just as with VMware, to have virtual machines in a failover state with each node having its own volume and being able to have your VMs on no matter what. When you create a VM, you can do it within the Failover Cluster Manager. That way it's already set up to be high availability. It is possible to move a VM that already exists into the shared storage so that it becomes high available. And then you'll configure the role and actions. In order to shut down a node, or at least the best way to shut down a Hyper-V cluster node is by either pausing and selecting the drain role. The drain on shutdown will drain any roles automatically and live migrate virtual machines to another cluster before that system goes down. Useful in order to keep VMs up without the VM knowing that there's something happening. You can implement node fairness, helping to optimize the usage of failover clusters or cluster node members. The VM movement, of course, happens with live migration. That way there is no downtime. The node loads are always figured out by the CPU memory utilization. So if a host is too busy, it probably won't receive the VM. But another one who's not so busy will receive the VM in order to keep it up. So you can set it to automatically balance within your cluster and how aggressive you want it to work. The resiliency can be set so that VMs are unmonitored, isolated, quarantined as needed. Any high available VM will lose access to storage when placed in a pause critical state. You can set up virtual machine monitoring on highly available VMs. Obviously, this is more of a Windows thing, so it should be a Windows host in the same domain as the Hyper-V host. And the user running the failover cluster manager should be a member of the local admins. It's one of those benefits if it's a Windows box. Then you'll set up a firewall rule in order to allow this monitoring to occur. And there it is. And there it is as well, on both within the VM itself and on the host. You can do guest clustering using 2 or more VMs with a guest OS and configuring it that way. This can help with monitoring clustered resources in the guest OS, Hyper-V optimization, and host failure protection, because talking with physical equipment, it's gonna fail at some point. So your VMs could use shared virtual hard disks or your VHDX files instead of a SAN in order to provide easier management between these VMs. There are some requirements in order to enable this, but it's totally possible for 2 VMs to be failovers of each other. So there's the where you would create the shared drive and select the VHD set. If we need to move a VM from one host to another, we have these options: the Hyper-V Replica, the live migration, the quick migration, storage, and VM import. The Hyper-V Replica is one of those automatics. If our site is down, then it'll, our hot backup site will take over. Systems have to be selected to be the replica server, so it's not done automatically. But you can authorize a machine to be the replication server. Then you can set the replication in a VM itself. You can set up a replica broker used to configure the replica between the cluster nodes. So it'll handle the management of the nodes. The extended replication is a backup of a backup, a replica of a replica. So if we have multiple data centers, we can enable this so that one copy goes to another and to a second and a third site, especially when we're talking big data centers. Another option for moving our VMs will be a live migration. They do need to have some settings, some similar configurations of each other. This is enabled by default on a clustered Hyper-V server. And you can do any of these: the cluster live migration with the shares, shared nothing live, or cross version live migration. If you're going to do a cluster live migration, you have a few more items to include. And to select it's within the VM in order to enable this. If you're doing it with SMB shares, it is also possible. Permissions have to be set up, of course, to grant access. And you'll need to set this up on the source Hyper-V server. The shared nothing live migration can be done with two Hyper-V servers that don't have common storage. So you do have that option in case you don't have a shared storage for the two. It is still possible to make the transfer. And the cross can be done between, like 2012, 16, or 19, allowing you to perform the Hyper-V update without affecting the downtime of a VM. Quick only happens within a failover cluster. This will copy the VM data to the destination node, saving the state. This is definitely something that would be done more locally. It is also possible to do storage migration, where you need to move a VM storage from one volume to another without moving the VM to another Hyper-V server. So the Hyper-V server is the same, it's the storage that we're moving. This can be done while it's running, while the VMs are running, or when they're shut down. So an idea of current storage is filling up, so we need to transfer, or we're upgrading the type of storage from a spinning disk to a solid state. And of course, the tried and true, Exporting and importing of VMs is another way of copying. There is the network health protection that'll move a VM from one cluster node to another if it detects that a network has been disconnected. It's a feature that you'll need to enable or disable if needed, if you're like going to manage it or take it offline. The storage spaces direct can do storage pools among all the nodes. And then any new nodes that are added, their storage can be added into this pool. So you'll need at least 2 to 16 servers. A high speed connectivity would be recommended. At least 4 locally attached drives. And you can either do the hyperconverged or the disaggregated method to deploy. As always, if you don't have the hardware to handle it, it won't work. You can enable this through PowerShell and create the pools. Then you'll take your new volumes and add them into the pool. To do hyper-converged, the storage and Hyper-V role have to be in the same cluster. Your disadvantage is when you scale, it's an all or nothing. But the advantage is there of one cluster to manage and less network traffic. So here's your hyperconverged, where we have our storage pool from these boxes together to create those virtual disks that our VMs use. In a disaggregated, you can do an S2D or a Hyper-V cluster. The Hyper-V cluster can be scaled independent of the storage cluster, so they're not tied together. The disaggregated will use the scale out FS and offer CSVs to the hosts. Awesome. This chapter was a little long and had a lot of info. Any questions? I don't see any anywhere. So as always, if you do come up with any questions, feel free to ask away in Discord. But like I said at the start of this, if you missed it, I know that this is the time when students start submitting more assignments because we're starting to get towards the end of the semester, believe it or not. And I am cognizant of it. So I will do my best to stay on top of all the assignments you start turning in, so you know your grade. But just know that I accept assignments all the way up until the due until date.